Hi everyone, today we're going to study addition of polynomials. First, let us define like terms. Like terms are terms with same literal coefficient, otherwise unlike terms. Let's have some examples here. I have here four terms: 2x, negative 5x, x, 3/7 of x. As I observe, the literal coefficients for all these four terms are x. So they have common literal coefficient. So these four terms here are like terms. Another example, I have three terms here. The first is 5a cubed b square c. Second, negative a cubed b square c. The third, the square root of 10 a cubed b square c. Now, observing the literal coefficients of all these terms, it is common, and that is the a cubed b square c. So we don't care about the numerical values or the numerical coefficient. Since they have the same literal coefficient, they are like terms. Third example, 10a cubed b square. Second is 10a square b cubed. In here, they have the same variables a and b. However, the exponents are different. In the first term, the power is 3. In the second term, the power of a is 2. While here, the b has an exponent of 2. In here, the exponent of b is 3. So they have different literal coefficient. So when we say the same literal coefficient, even the powers must be same. So in this example, for this group of terms, these are unlike terms. Fourth example, I have here two terms, 2a cubed b square c. The second is 5a cubed b square. So in the first term here, I have three variables a, b, c. In the second term, I have only two variables a and b. While it is true that the exponents for the a and b are same, but in the second term, the variable c is missing. So in this case, this is an example of unlike terms. Let's go now to addition of polynomials. Let's begin with addition of monomials that are like terms. The rule is given to add the numerical coefficients and copy the common literal coefficient. Let's see an example. 3xy plus 2xy plus xy. So we are sure that this group of terms are like. So we can add the numerical coefficients. I collected the 3, the 2, and the 1. The 1 is the coefficient of the xy. And then for the literal coefficient, we simply copy that same and common literal coefficient. So 3 plus 2 plus 1 gives us 6, and the xy, the literal coefficient, is simply affixed. Second example, 10xy square z cubed plus 4xy square z cubed. Again, looking at the literal coefficients, we are sure that these two are like terms. So we can now add the numerical coefficient. So the 10 plus 4, and then we copy that common literal coefficient, the x, y square, z cube. So the final answer is 14x, y square, z cube. Third example, 4xy square plus 2x square y. Looking at the literal coefficients, it seems there is a problem here. In here, x, y are there, but the coefficients as compared with the second literal coefficients are not same. Here is x with exponent 1. Here there is an x with exponent 2. For the y, here is exponent 2. Here is with exponent 1. So we can see here that we can conclude that these two terms are dissimilar. And it says dissimilar terms cannot be combined. So when we are required to put the answer here, we simply copy that same problem. So our answer here is, I simply copied the 4xy square plus 2x square y. Let's go now to the addition of polynomials. The rule says combine like terms. Example 1. Simplify. There is a group of polynomial here, 6x squared plus 2x plus 3, plus the second group, 4x squared plus 5x minus 1. So the rule says let us combine like terms. So the 6x squared is combined to the 4x squared. We will get this 10x squared. Next is the 2x and another 5x on the other group. We can put them together. So we add the numerical coefficients. 2 plus 5 gives us 7. And we copy the x. And for the constants, here is 3. In the second group, there is negative 1. So 3 combined to the negative 1 will have the positive 2. So the final answer is 10x squared plus 7x plus 2. Let's see second example. Sometimes problem will come to you like this. Find the sum of the polynomial 2x squared minus 3x plus 5 and the polynomial 5x squared plus 4. We can rewrite this problem like this. Put a grouping symbol to the first group, list here, and then put a plus sign. Then take the second group, put a grouping symbol, and place it next to the first group. And then we will go now to combining like terms. So here we have 2x squared. Here there is 5x squared. We can write the answer as 7x squared. And for the negative 3x, there is no term in the other group with the x as literal coefficient. So the negative 3x directly we can place in the sum. Make sure that you don't forget to include that negative 3x. And for the constants, the 5 plus 4 will give us 9. So the final answer is 7x squared minus 3x plus 9. Example 3. The three sides of a triangle is measured at 3x minus 2, x plus 1, and 2x plus 7. Find the perimeter of the triangle. First, we should know that perimeter is the sum of all sides. So we're going to add the sides of the triangle. So P, that stands for perimeter. So I collected the 3x minus 2, that is the first side. x plus 1, that is the second side. The 2x plus 7, that is the third side. And then we simply collect the like terms. The 3x, the x, and the 2x, we combine them together. We'll get the 6x. And the constants, negative 2, the positive 1, the positive 7. We will get a positive 6. So 6x plus 6. This is our final answer. This is the perimeter of the triangle. Thank you for watching. See you again next time.